Okay, so we have our next question right here. It says a skittle is a wooden object that can stand upright on one end. In the game of skittle, a ball is thrown at some skittles to knock them over as shown. Diagram below shows like the ball just before it collides with the skittle. The graph is shown for this, okay? And then they ask you to determine the average acceleration of the skittle during the collision. Average acceleration, how will you find it? So basically, you should know that acceleration is basically change in velocity, right? Change in velocity. And if you don't know the formula, which is A is equals to delta V by T. Okay. So this, for example, this area right here is where the change of velocity is occurring, right? It's increasing. So what you can do is take any 2 points. Let's say I'm gonna take 1 point here and 1 point right here. Okay. So now if you write it out, remember it's in millisecond time. I just saw that as like milliseconds. So divide by 1,000, whatever the time is. So velocity is what 0.4. No, sorry. Wait. From highest to lowest. So it's 2 minus 0.4 divided by 2 has 38 minus the 22. I think, yeah, 22 divided by 1,000 as well. Okay, the whole time, and then you will get your answer as 100 meter per second. I got my average as like this. You can maybe have a different average than me. For now I got the average as 100 meter per second square, so you just write the exact same stuff right here that I wrote back here, and your final answer is 100 meter per second. So yeah. Okay, so we have a next question right here. It's an aesthetic question. It says explain me the Newton's second and third law when during the collision, well, it applies to the ball and the skittle during the collision. So it's simple. The ball will go here and it will collide, right? Of course, during this collision, Newton's third law will appear. Okay, Newton's third law will appear. What it says that every action is equal to equal and opposite reaction. What is meant by that? Every action has equal and opposite reaction. So it means that once it collides, the skittle of course will go to the left, and there will be a little bit of force to the right which will cause this ball to decelerate a bit. Okay, so I don't know if the ball is gonna just like stop immediately, stop there, or will go a little bit more right, but it's like it's gonna decelerate 100% for sure, right? I can give you that for certainty, but I don't know that if like the ball is gonna stop there once it hit the skittle or not. So that's that. But it will have a little bit of force there, so it will decelerate, of course, and it will go, the skittle will go to the left side, right? There will be a resultant force towards the left side, right? And to explain why it's going to the left side, you will have to use Newton's second law, right? Newton's second law. What it basically says, it's the formula of F is equals to ma, right? So force is the product of mass and acceleration, so it will accelerate due to the Newton's second law, right? That's the simple thing. It's just the formula. So you just have to say, okay, well, uh, acceleration happens due to Newton's second law, and during the collision, right, Newton's third law apply, where every action has equal and opposite reaction, where the skittle will go left, the ball will decelerate a bit, and yeah, that's it. You just have to explain the whole story. So you will write that the ball applies a force to the skittle, right? And basically the skittle will apply the, not the, like a force to the ball. Same thing, Newton's third law. Every action has equal and opposite reaction. The ball will apply a force to skittle, skittle will apply the force to ball, right? So this is Newton's third law. Sorry for the bad writing. Newton's third law, where it says every I where you also write where it says every action as equal, equal and opposite reaction, right? So you will write this, and then basically now you have to explain the Newton's second law. What is it? That it will have some resultant force, right? Resultant force, there will be some result, there will be, let me rewrite it. There will be resultant force on the skittle, right, which is to the left, right? Skittle, let me see the spelling. Yeah, skittle. Okay, so there will be resultant force to the skittle where on the left side, right? Newton's Due to Newton's second law, there will be acceleration. Due to Newton's second law, there will be acceleration, right? Because if you want to write Newton's second law, you can say Newton's second law says that force, you can say the Newton's second law definition as well here. I'm not going to write it, but you can write it as well because it's going to take more time, right? It's the same F is equals to ma, right? Force is the product of mass and acceleration. And then yeah, and you also have to also mention that the ball will decelerate as well, right? While it has a resultant force on the skittle towards the left side and it accelerates there, right? The ball, on the other hand, will decelerate. Okay, mention the acceleration, deceleration, resultant force, right? All of these things, and for sure you will get the 6 marks easily. It's like a simple concept, but they ask you to write it more, describe them more, and write it in a proper format so that you can get the marks easily, right? And explain everything step by step. So this is your final answer, like an example answer. Okay, so we have the next part here. It says the ball is thrown again. It collides with another skittle. During the collision, the horizontal velocity is changes from this to this. The horizontal velocity of the skittle after the collision is this, in the same direction as the ball. Determine the mass of the ball. Okay, so you can use the conservation of momentum, which is m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Final velocity, initial velocity and final velocity. V is final, u is initial mass of basically the ball, and the mass 2 is the skittle mass, right? So we need to find m1, which is the mass of the ball. We don't have that, but we do have the ball's velocity, which is what, 7.2. So you need to find the mass plus m2 is given, which is 1.4, which is skittle mass, and the velocity for it was 0. So it will this whole thing will become 0, and because it was stationary before, right? Stationary as mentioned here. And mass we need to find, and velocity changes to 1.6, same direction as that, so it will be positive. The velocity will be positive. If it was in the other direction, then it would have been negative. Yeah, so and m2 is 1.4 and it times with 3.1, and then if you just basically do this times, it basically becomes 7.2 m minus, if you shift it on the left side, it's 1.6 m is equals to, this becomes 0, so you don't have to worry about it. This is 0 because anything multiplied by 0 is 0. So 1.4 times 3.1, you're left with 1.4 times 3.1, right? And then you basically, once you calculate all of this, you can just divide them it, like 1.4 times 3.1 divided by 7.2 minus 1.6, right? So if you solve this whole equation, you will get your answer as 0.775 kg, rounded off to two significant figures, as you can see from here, like either one decimal place or two significant figures. So it's 0.78 kg for the mass of the ball. Okay, So this is your actual final answer.